Hello, everyone. Thank you for joining us. My name is Cassia Martin. I'm a security solutions architect in AWS. I'm based in New York City, and I primarily work with our global financial services customers to help them build a strong foundation of security and to analyze workloads and answer security questions, particularly around identity and data encryption and all sorts of different security concerns that people have to make sure to protect your banking data. We're here today particularly to talk about identity. And in particular, I'm going to share with you 10 health checks that we can use for identity to make sure that we're improving security in the cloud. This talk is inspired and modeled after Steve Schmidt's security leadership session from reInvent 2019. He's covering a broader base than me. He's discussing the top 10 places you can get the most bang for your buck in all of security. So not just identity, but logging and monitoring, data encryption, incident response. Generally, his goal, his presentation, was talking about how to make sure your application is well architected from a security perspective. I'm going to include a link to his talk and all the other resources that I'm going to talk about today at the end of this deck. So for me, let's talk about identity. What does that mean? Identity is the system you use to authenticate your users and authorize them to give them access to all the right information that they need to do their job. The foundational service for identity at AWS is IAM, Identity and Access Management. If you're using AWS at all, I promise you you're using IAM. All of our services use it as a way to make decisions about how to grant access to all their resources. So with IAM, you can create and manage AWS users and groups and use permissions to allow and deny access to various AWS resources. My customers frequently ask me for prescriptive advice for AWS identity. They know and they value that AWS platform provides tremendous flexibility, but they also want to hear from us directly what we think best practices look like. So that's what we're addressing today with this idea of an identity health check. I'm going to give you an actionable list of 10 checks that you can do to make sure you've written your AWS environment in a way that matches our experience of what best practices look like. So through this, I'll share deployment best practices and talk about how to implement a strong identity foundation. With no further ado, here's the list. Number 1, use multiple AWS accounts. Number 2, create an intentional OU structure. 3, use SCPs. 4, secure root. 5, federate identity for human users. 6, use roles. 7, validate your trust role policies. 8, continuously review your policies. 9, audit IAM for unused principals. And 10, monitor your resource access. I'm going to talk through each of these, and I've grouped them into 3 categories. So the first 3 categories are around the concept of multiple accounts and organizations and how you, and all those things help you scale and manage the complexity when you have maybe more than one application, more than one workload, more than one user. The next category of 4 through 7 fall under the category of your users, right? How do you authenticate them? How do you make sure you have the right users with access that are connecting in the right way? And the last 3 are around the category of permissions. So they're about authorization. How do you make sure, once you have your users in your accounts, how do you make sure that they have access to the minimum information that they need to do their job? So let's start at the top and look at number 1. When you first sign up for AWS accounts, you'll probably sign up with an email address and you'll put down a credit card to pay for it. As you turn on additional AWS services and add more and more IAM users to your account, you'll start to use AWS's extensive security controls to manage your permissions, make sure people only have the minimum access they need. There are some limitations to that approach, and you'll soon start using the most powerful security boundary, which is the account boundary. You should be using multiple AWS accounts. This is powerful. It has advantages for things like managing production versus test versus development accounts. It helps you with cost accounting, so you know where things come from. And most importantly, for today's purposes, it gives you account isolation. Now, as you create your second and third and 10th account, you'll quickly discover another powerful AWS tool to help you manage all your accounts. And that tool is AWS Organizations. Organizations lets you create groups of accounts with things called organizational units. You can then apply policies either on an account level or to your whole organization, or in between on the OU. So you can centrally manage policies across multiple accounts without requiring custom scripts and manual processes. Do note that an AWS account can only be a member of one organization. When you enable AWS Organizations, you'll want to turn on the All Features mode. This is the default feature set. It gives you access to advanced features, and it gives the management account of the organization full control over what the member accounts do. Also, including making sure that member accounts can't leave the organization, and it enables consolidating billing. So I mentioned that AWS Organizations lets you have multiple accounts under it, and it also lets you create organizational units to structure your account. So that's my second health check for you. Make sure you're using an intentional OU structure. Take a look at your AWS Organizations environment. It's a very powerful tool, so as you use it, you should make sure that your organizations reflect your business, your workloads, maybe even your business structure. So there's two tools that AWS provides to help set up your multiple account infrastructure for you. Those two are AWS Control Tower and AWS Landing Zone. Now, both of them are powered by AWS Organizations, but they automatically implement this organizational structure that I have shown on this slide. Now, this reflects a set of best practices that you can use, developed by us based on the experience that we've seen in our customer networks. Now, regardless of whether you use Control Tower or Landing Zone, or whether you run your own organizations, either way, you should be thoughtful about your multi-account structure. Organizations lets you group accounts into OUs nested up to 5 levels deep. So look at your accounts, group them into OUs. This prescriptive example that I'm showing you specifically requires 2 OUs, one for security, one for infrastructure, and has additional OUs you should consider adding. For example, a sandbox account, a quarantine account, maybe some different workloads accounts. So take this one, or use the one that Control Tower gives you, or spend some time building your own. But make sure to do it in a thoughtful way. Now, once you have organizations with your multiple accounts and your thoughtful OU structures, another extremely powerful tool you get is service control policies, or SCPs. SCPs are a guardrail. They're an immutable security control that you can enforce. And you can enforce it at the account level, at the organization's level, or at the OU level. It basically lets you write rules about what that account is allowed to do. So you can define a list of APIs that are allowed, or define a list that's blocked, that can't be overridden by a local administrator. So even the root account in something that has an SCP applied to it will still be strictly controlled by that SCP. So after you group your accounts into OUs, you should apply SCPs for guardrails. Remember, SCPs don't grant any permissions. They're only guardrails. They're necessary but not sufficient for any user to have access. So what I've got shown here is just a list of example SCPs that you might be interested in. I find it very common in my customers that they'll write an SCP to restrict region access. So they know they're only in US East 1 and US West 2, then they'll just write an SCP for their entire organizations to deny access to any other regions. You can also deny access to AWS services that you don't intend to use. So that can prevent any extra risks or cost risks, potentially, of things being used that you don't want. Or you can prevent principals from making certain changes. Just an example of some of the power of SCPs, if you had a quarantine OU of the kind we talked about before, you could restrict the principals accessing that quarantine OU to only your security operations team. If you're very mature, you could restrict a production OU so that only automated machine-based access can use an SCP. You'll find this list and the written examples of what these SCPs look like at the resources at the end of this deck. Number 4, secure root. Now we're transitioning into talking about our users. The root account, the one you signed up for with that email address when you first signed up for an AWS account, you should use that never. Approximately never. There's some set of administrative capabilities like changing your support structure that do need root to accomplish, and you can find a link for that in our documentation. But with those exceptions, you should really be thinking of root as an all-powerful break glass capability. It's available for emergency fixes, but you shouldn't use it every day for operational activities. Because it's too powerful, it can do anything. So don't use it, just lock it away. Delete access keys, use SCPs to make sure that you can't do everyday operational activities with root, and we've written a blog post that you can follow along to monitor and notify you anytime anyone logs in to that root account. Some additional techniques you can use to enforce secure root access. You can enable multi-factor authentication, or MFA. MFA, we already have a password, that's something you know. With MFA at AWS, you can also have something you have, either a hardware or a digital token, which you'll have to type in when you log in. If you use the hardware token, you'll want to connect every 3 to 6 months to make sure there's no time drift. The password that you're using, that shouldn't be anything you could keep in your head. It should be a strong, random password. AWS allows up to 128 characters. Use more rather than less of that space. If possible, you should also split your control. Have a system where you need 2 hands on the keyboard. The person with access to the token should not also be the person with access to the root password. And finally, take steps to protect the root account recovery process. So that email address that you have signed up, it shouldn't go to a person who might, leave your company or not be checking anything on their vacation time. Instead, set it to a distribution list so it can reach a whole service team who can be responsible for that. And similarly, for the permanent telephone number on the account, have strict controls over who has access to answer those calls. So we know we're not using root to log in. So how are we logging in? What identities should we be using? My answer is number 5, Federate identity for human users. Now, unless you're born in the cloud, you probably already have some kind of corporate user directory. You'll have something like an Active Directory or an LDAP or Google Suites emails. That corporate directory is the source of truth for who works at your company. You shouldn't have 2 copies of that. You shouldn't be maintaining an extra set using AWS IAM. So that's what federation means. It means don't keep a second copy. Instead, configure AWS so it knows how to ask your company's existing corporate user directory who the validated users are. When we avoid creating human users in IAM, we're also moving away from long-lived credentials in AWS. When you set up federation, it allows you to reuse identity in step with your business processes. One easy way to set up federation is to use AWS SSO, our single sign-on service. It allows you to manage SSO access and user permissions to all your accounts in an AWS organization. There are tons of great partner tools also. Things like Azure, Okta, OneLogin. Those are services that you can use to manage as identity providers, or IDPs. Any of those IDPs lets you establish a trust relationship between your corporate accounts and your AWS accounts. Now, federating identity, that's given us a dynamic way to authenticate to AWS. Now we have to talk about best practices to give them access to AWS resources. Federated users, remember, don't have permanent identities in AWS the way IAM users do. To assign permissions to a federated user, you have to create an entity known as a role. So that's number 6. Make sure you're using roles. You absolutely need roles to use federation, but even if you're using standard IAM users, you should still be using roles. They're a good idea for everyone. You can define role-based access control based on a job function and using the principles of least privilege. So roles, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role doesn't have a long-term credential, like a password or access key. Instead, it gives you temporary security credentials for the duration of your role session. One other thing about roles. I've been primarily talking about human access, but you can also use roles for machine users, for applications that run on Amazon EC2 instances. You can give those external entities permission to use AWS resources in your account, and then IAM identity helps keep your AWS account secure because you don't have to distribute long-term credentials like access keys in your application. So, here we go. We're authenticating our users using federation. You're creating an IAM role that grants authentication to appropriate data. The missing bridge between these two is a trust policy. So here's number 7, validate your trust policies. The trust policy is the place where you define the principles that you trust to assume the role. And when I say principle, that's something you specify in your trust policy. A principal can be a user, it can be a role, it can be an account, it can be a service. When you're using federation, a principal is your IDP, your identity provider. And the trust policy is the mechanism for associating your federated user with your role. So how do we structure that properly? Here's some basic do's and don'ts that we've pulled together from our experience with customer environments. It helps make things more maintainable and secure. First, grant least privilege. Make sure that you look in your trust role policies to make sure you're not granting any broad access. If you see anything like STS assume role star, that means you're granting a principal access to all your different roles in your accounts, and there's no reason to do that. Next, simplify. You should limit the roles to one level of role assumption. If you end up using role chaining, like you have a setup where role A is able to assume role B, there's nothing wrong with that from a theoretical security perspective. It'll work fine. But my experience is that makes it harder to do incident response and harder to understand who did what. So these role hierarchies just complicate attribution. So whenever possible, just have one level of a principal assuming a role. And third, segregate the different purposes of roles. You should have different roles for humans versus machines. And you shouldn't let multiple applications use the same role. So this covered our 2 broad access. We talked about how to set up your account structure and how to authorize users. For the rest of this talk, let's talk permissions. The principle of least privilege is a foundational security principle. It says you want to have the minimum access necessary to do your job. So we know we're trying to avoid broad access to our data. How do we do that in AWS? You do it with 8, continuously reviewing your policies. When you first start out, there's one really useful tool to help you do this. It's IAM Policy Simulator. It's kind of a sandbox. It takes a question, a command that you would normally run, and you can run it without it doing it. So you could safely ask a question like, would Eve be able to delete the database? You can do that in Policy Simulator, and then you can get a yes-no response to whether she has those permissions without needing to risk actually deleting the database. So Policy Simulator is particularly useful when you're first creating an account. But you should also be reviewing your policies continuously. And the most powerful tool for that is IAM Access Advisor. Of course, you can manually review your policies, and you should. You should be looking for things like star.star or any principals that have really broad access to data, like S3, GetStar, DynamoDB star, etc. But another way that's more granular and more automated to review your policies continuously is Access Advisor. Access Advisor gives you a report. That report gives you a list of services and timestamps for when they were last used. This service last access data is available for your accounts, OUs, and your organizations. And you can use this to find any services that aren't being used by IAM users and roles. One example of how you could use this. You could identify the services that aren't being accessed in, let's say, one given OU in the last 90 days. Then you can take a control we talked about earlier, SCPs. You can create an SCP that denies access to those services. Then you attach the SCP to the OU, and so you restrict access to all IAM users and roles across the accounts in the OU, and you have data to back up the fact that in the past 90 days, no one has needed that access. So it tightens the permissions, gives you more granular access in a lower risk way. So that covers unused permissions. You should also be deleting any principals who aren't using your account. A tool to help you do that is the IAM Credential Report. So here's our number 9, Audit IAM for unused principals. This tool will help you delete stale or unused account keys or IAM users or roles. It's given to you as an CSV file. You can generate it via the console or the API. So you can ask questions like, is there a password enabled? In this case, there is no password enabled for root, so that's very good. When was the password last used? Oh man, it looks like in this example, Bob's never logged in, so maybe that means we don't need the account. You can also gives you information about when it was last rotated. So if you have any policies that every year you have to rotate your password, something like that, this would be the place to check that. In addition to accounts and password login, it also gives you information about access keys, API keys. So you can check if those are enabled, if they've been rotated, if they've been used, and you can use that to make decisions about maybe whether somebody's access is no longer required. So the last item on our list today is number 10, monitor your resource access. It's still about permissions, but it's from the perspective of resources. The goal is the same as always. Aim for least privilege. One really powerful tool for that almost everyone should be using, is S3 block public access. This is a feature, a capability of S3 that overrides all other S3 permissions. It's designed as an easy, centralized control that you can just turn on. And when you turn it on, you've blocked all public access. It applies account-wide for all current and future buckets. Another tool to help you monitor your resource access is IAM Access Analyzer. This was introduced at reInvent in 2019. It's a tool that came out of our automated reasoning group, whose goal is mathematically provable security. So the particular questions it answers is, what is shared outside my account? What is shared outside my org? And you can build detectors to ask those questions in whatever regions you're using. The types of resources it monitors are S3 buckets, IAM trust role policies, we talked about earlier, KMS keys, Lambda functions, and SQS queues. Basically the resource types that support a resource policy. So we've covered our top 10. Does that mean we're completely done? Well, no, there's always more. As somebody who's worked in security for far too long, I can tell you we never feel like our job is done. But I've covered the top 10, and I really do believe that these are the items that can bring you the most value with the least effort, and that can be very actionable. If you get to a place where you've done those and you're looking for more, or you've reached an extra level of maturity, or you're aiming for an extra level of granularity, or you have additional requirements, there's a lot more that AWS has to offer. So I'm definitely not going to go through these in any detail, but just to talk about a couple. My customers really appreciate permission boundaries. There's always this tension between having a central security team defining all the permissions. That gives you consistency and security. But if you have developers write their own permissions, that gives you speed and innovation. So permission boundaries is something that gives you the best of both worlds because it allows development teams to create permissions, but within strict boundaries defined by permission boundaries. All sorts of powerful constructs that you can use with conditions in IAM, things like with KMS integration, making sure your data is encrypted, making sure you have access keys. Another really nice thing to look at is our instance metadata service. Our version 2 gives you an extra layer of protection against misconfigured firewalls gaining EC2 security credentials. And certainly, last but not least, automation is always going to be a huge focus of any security team. And that's just as true in identity as in everywhere else. If you can spend time building CloudFormation templates with well-secured blueprints or vending well-formed accounts through Service Catalog, those are some extremely powerful tools to help with automation. But start with these 10. Here's the takeaways. You should have multiple accounts. You should use organizations to manage it. You should use SCPs within organizations to help you with guardrails. For identity, identity should be federated. You should never use root. You should have highly granular roles and be very strict and limited about the trust policies so that you know who's getting access to those roles. And finally, you should use our AWS tools that we give you, like Credential Report, IAM Access Advisor, Policy Simulator, and IAM Access Analyzer to help you achieve least privilege. If you follow these items, these are the places to start to give you a strong identity foundation. Make sure you have granular access to data and granular access to roles. So here are some of the resources that we talked about today. So Steve Smith's talk, you can get a list of top 10 security items. You'll also find examples for SCPs, a list of the tasks that require root, and one really nice lab on federation to help you step by step actually set up the work for how to federate your users. Thank you for your time today. Good luck on setting up your identity foundation. And don't forget to complete our session survey.